welcome to our next installment of our continuous quality innovation series. This one entitled Accelerate Development Cycles, Reduce Bottlenecks, and Decrease Time to Market. And today we'll talk about testing strategies that can actually help reduce your time to market by up to 50%. Okay, so just an example here, right? We've got JPMC, who's done an outstanding job of implementing some automated testing strategies that actually did reduce their release time by 50%. And they did it really three ways. And again, there's a whole article. There's a link at the bottom of the slide for the whole article. It is not a Sauce Labs article. It is an independent article that really dissects what they did. But really the three key items here that helped drive their success was, first of all, just trusting in their small, highly focused teams. Again, they've got a lot of development teams around the world. And they put a lot of trust in those teams to focus on what they do best and deliver the best banking experience for their customers. They actually did integrate automated testing and pipeline management, which maintained their platform quality and stability goals. And that actually led to a focus on stability that helped to decrease their crash rate per customer from 0.03% in 2022 to 0.01% in 2023. So, while the percentage numbers seem small, when you're talking about 10 million customers, that actually is a pretty good number. So when we talk about continuous quality, you got to look back a little bit, right? When you look at traditional testing, right, it was typically, you had a bunch of developers develop code, then it went to the QA team, they did the testing, any issues then went back to the development team, right? And so there was a shift left eventually to become more efficient. And it was essentially, while you're developing code, test your code while in development, right? Faster feedback loops, able to find the bugs and fix those bugs faster, enabling you to release faster out to the market and drive more value, not only for your customers, but also for your company. And then there is a shift right where you're not going to find 100% of the bugs all the time, right? It just takes too long, it's too expensive. So companies were releasing fast and wanted to maintain that velocity and accept a percentage of bugs going out in production, right? So, but then they were looking at solutions to make sure that they were mitigating and managing those errors in production so that they could find the ones that were impacting the users the most, get them, collect them, triage them, and resolve them as quickly as possible, and maintain that continuous quality for their software throughout the entire software delivery lifecycle. But there are challenges to running fast, right? There always is. If you're running too fast, you're going to trip, right? But when it comes to software delivery, there are challenges in trying to release very fast. One is wasted time, right? When it comes to testing, developers are waiting up to 16 hours for their CI builds to complete, right? In a QA cycle. That's 2 whole days that you've got developers maybe doing nothing, right? And sitting and waiting in idle time, right? That translates into wasted money because now you've got a 38% increase in costs of your FTEs, your full-time engineers that you're actually hired to do a job, right? But if they're sitting waiting for a build to complete or a test to complete, waiting for the feedback, now you're wasting money. And then that translates into wasted focus because now you've got hours of time of a developer, right, that was focused on doing something, stopped, and waiting, which means now they've lost their focus, right? And a lot of research have shown it takes you, like once you stop a task, it takes you 30 minutes to an hour to actually get back into that task, right? So not only are we wasting 2 days of time waiting for a build to happen, and you're wasting money doing that, but now you're wasting another 15 hours or almost another 2 days just for folks to kind of reshift and get their focus back into what they were doing, right? So that slows everything down. So let's introduce our panel today. Marc Hornbeek, I'll let you introduce yourself first.
My name is Marc Hornbeek. I claim I've been doing DevOps and continuous testing related things for like 50 years. I literally celebrated my 50 years of engineering last month. And I spent a lot of my career in this area with automated testing, related quality testing, security, and feedback type things. So I currently run a little boutique consulting firm called Engineering DevOps Consulting. Mostly I work with large clients and help them with their transformations to continuous testing, DevOps, DevSecOps, and SRE practices. I also do a lot of writing and content creation and stuff. I finished publishing a recent book called Continuous Testing, Quality, Security, and Feedback, which anybody attending this today will get a free PDF copy of that if you're attending today. So welcome, and feel free to ask any questions. If I can help you in any way today or any other time, please let me know.
Excellent, Mark, and thanks for taking the time to join us today. Really looking forward to hearing your perspectives based on your expertise and your experience and your knowledge. And Marcus, please feel free to introduce yourself as well.
My name is Marcus Merrell. I'm a principal technical advisor here at Sauce Labs. I've been at Sauce for 6 years. I was a customer for 8 before that. And I've been in quality assurance testing, test architecture for 25 years and software for 30 overall. I started in gaming, which is, kind of awesome. But so I came here because I wanted to make sure that, Sauce is continuing to produce really, really good, innovative products for people in the testing industry. And mainly I came because it was a chance for me to get to market some of the tools that I fantasized about having when I was in the testing industry itself. So I'm very glad to be here today. I'm glad to be talking with another Mark with a C about this opportunity.
Yeah, excellent, Marcus. Thank you. And if anyone's had the opportunity to be on other webcasts with Marcus, again, very knowledgeable, a lot of experience, a lot of knowledge. And again, looking forward to the conversation to get perspectives from both of you. All right, let's get into the discussion. I'm going to start with our esteemed guest first, Marc Hornbeek. Mark, so related to software testing, what are some of the things that can actually slow delivery velocity?
Many things. Because testing is more than just automating the execution of the test, workflows. There's the test analysis process, trying to understand requirements, then strategizing the test, planning the tests, implementing the test cases, and implementing the test environments, and getting results, running the tests, analyzing the results, going back through the loop in order to fix the problem. So there's so many points in any one testing cycle, if you like, that can be a bottleneck depending on what tools and processes you're applying and who has to be involved. So it's often people related, collaboration, coordination type things that tend to slow down delivery velocity because some of those workflows maybe aren't resourced properly or set up for efficiency properly. And that's only, for every type of test. And depending on the product, there can be many different kinds of tests. I mean, I literally talked about 43 different test types in a CT course that I did for the DevOps Institute. So that whole cycle repeats again and again. So testing tends to be the largest, bottleneck in most value stream. That's what I found as a consultant. It's usually like half the bottlenecks are testing related. And often the solutions are to improve the way you're doing testing or else improve the testability of the product itself so that it can improve the velocity for testing.
And when you say improve the testability of the product itself, can you dive into that a little further?
Yeah, testability to me is a combination of two things, controllability and observability. So if you want to test something, you first of all have to put it into a state where you can, run an experiment if you like a test, and then you need to observe the result. So it is possible to build any system, but it's a black box. So you really haven't got the right controls and don't have the right observation points. So if you have good control and observation, then you have good testability. It makes it an awful lot easier to be efficient when you're testing. If you don't have that, it can actually, in some contexts, be almost impossible to validate something or to test something. But that's what I mean.
Marcus, any thoughts on this question or anything that Mark mentioned?
I mean, from a tactical standpoint, I think that what slows delivery velocity is either high maintenance tests where, either the product is changing a lot and you have to change the tests to accommodate, or the tests themselves are brittle or flaky and you can't trust them. And I think that the lack of trust issue and flaky tests, as well as a high failure rate, it's the killer of automation efforts, honestly. I've worked with a whole bunch of companies as an employee and as a manager where at some point there's so much red in the test results that nobody pays attention to it anymore. So if you have 800 tests and 200 of them fail nearly every time you run the tests. And then several things are happening there at once. You're failing to maintain the tests, and nobody trusts what they actually tell you. The second thing is that if that number fluctuates from 200 to 201, and that 201st test that fails is a sev zero, prize zero, absolute must fix stop ship, nobody's going to know, because they're not doing the analysis already. And then finally, the last thing is that you're misrepresenting to your management exactly what you are testing, because you have a list of 800 tests. You say, well, we're automating all of these, they're all working. But what you're probably not telling them is these are the 200 that we have to go in and analyze manually, because they're not actually being covered. So I've seen that more times than I can count. And I think I've only seen a true green build, handful of times in my career. And those are the teams that are wildly successful and actually contribute to velocity and confidence.
Awesome. Excellent. Thanks, Marcus. And Marcus, don't go away, because I'm going to ask you, I'm going to start with you for the next question. So how should product teams think about testing as a method to aid in velocity versus hinder it?
Yeah, the way I think that product teams should think about it is I mean, it absolutely should aid in velocity, because otherwise, what are we doing? Either we're testing manually and it doesn't scale and it's not repeatable, or it's automated and it's, if it's not helping velocity, it's automated and it's bad, it's not trustworthy. I think that how product teams should think about it is look at it as risk mitigation, risk management, not as a box you have to check. Look at it as something that can help you. I think the main advice I would give product teams is to also be a little bit critical, but also act as a partner and an advisor to the testing teams as they build out their test suite, so that they're not testing stuff that doesn't matter. There's a lot of stuff in your software that frankly doesn't matter. It doesn't help or hinder your bottom line. It's not something that your users see all the time. And in a lot of cases, you might as well skip it if you don't have time to do the more important stuff.
Excellent. Thanks, Marcus. And Mark, how about your perspective on this question? What are your thoughts around this?
Fundamentally, I believe in what Dr. Edward Deming, the late great Deming, said, that quality is everybody's responsibility. And honestly, I get sick and tired of hearing developers telling me that, hey, we have a QA group, they take care of quality. And it's not really the developers' fault necessarily, because they're not incentivized, trained, motivated, or supported to do adequate testing. But, when they are, it works out much better. So product teams that are positioned to really embrace quality and testing as part of their development work, rather than relegating it to some separate phase of QA or something, tend to be more effective. But that doesn't happen overnight. It is a mindset, as well as having the right training, motivations, tooling, processes that are efficient. I'm not saying you shouldn't have a separate QA team. In many cases, that's important too for independent QA validation, especially in complex systems. But I think product teams really should really think of testing as an integral part of their daily work, and not something that's separated from the process of design and implementation.
So how can dev teams improve their testing strategies, right, to remove bottlenecks in their SDLC? Almost like one click down from the last questions we just had.
Yeah. So first of all, again, learn about testing. I actually run a continuous testing certification class, and usually about half of the folks that show up are developers and half are from QA. And the developers start off the class typically saying, what am I doing here, type of thing. I've been told to go to this class. And by the end of the class, they realize, wait a minute, if I really understand testing better and how to do it properly, then, I'm going to get a lot more efficient, effective development. And it's going to be a lot more fun, because I'm going to get feedback faster rather than waiting for some other buddy to come back with results sometime later. So training is one way to remove bottlenecks. Again, mindset, just to think about testing as part of the job, not something that's separated from the job of development. Implement tests early, right? I mean, don't wait until sometime later in the process to automate testing. The idea of test-driven development, application test-driven development, and that type of thing, where you actually create tests, even in front of the functional code can make sense. If you're not familiar with that approach, it doesn't sound like it makes sense. But those that are familiar with it realize that you can get a lot of value, and it actually makes a lot of sense to try to treat the tests as kind of a specification for the code, and then validate the code changes against the specification, which is a test. That way you guarantee you're having tests along with the code. So when you do continuous integration, the tests are already ready, and it's going to make the rest of the process a lot smoother, a lot more efficient, and a lot more satisfying for everybody, including the developers.
Marcus, your thoughts?
I'm someone who has seen the light on test-driven development. I mean, even just 2 to 3 weeks ago, I was making some changes to a test framework to try to add some simple tagging in there, and I thought, oh, this will be easy. And then the unit test broke, and it revealed all these implications about what I was doing to create these tags that I hadn't really even considered. And so I think that people need to understand that if you hate TDD, test-driven design development, if you really think that it's a waste of your time, my bet is, and I'm not impugning or accusing anyone, but my bet is it hasn't saved your butt. And one day it will. Like, I think that it's seen as a waste of time by people who haven't achieved velocity as a direct result of it. And I just, having now been in that boat 3 or 4 times and thinking, oh my gosh, what would it have been like? How much longer would I have had to work on this code if I hadn't had those tests in place? I think there's a lot about testing. Unfortunately, that is kind of like the referee in sports, in that you don't notice the testing until it screws up. And once it screws up, you're like, well, let's just get rid of all of it because it's not helping us. But the truth is that if it's done well, it's invisible and it does help you out. And what we need to do as testers, people who believe in this profession, in this quality, this motion, we need to trumpet our successes, and understand that it's all real.
Awesome. And Marcus, I'll keep you here. For the next question: how can automated testing help accelerate software delivery? So let's get right into, why automated testing, right? How does that help around velocity?
I mean, for me, it starts with unit testing. Unit testing, by definition, is not by definition, but at least by implication, is almost exclusively automated. So you write a test to make sure that the single units of your code have code paths that are well understood and not broken by subsequent changes to that code. And if those tests are executing automatically every time you make a change to your code, then they're almost like scaffolding, holding the thing in place and making sure that nothing is falling down, nothing is broken. And they're support structures that you have that, if they are in place, they accelerate software delivery by making sure that you catch problems at the beginning, not at the end. And this metaphor can be extended to all phases: integration testing, API testing, UI testing, post-release testing, production monitoring, that kind of thing. Your acceleration seems slow at first, but then once you've seen the light, you realize that slow is smooth and smooth is fast.
Awesome. Thanks, Marcus. Marc Hornbeek, what is your thoughts and your perspective on this question?
Well, first of all, I would just like to comment that I concur with the use case that you put up at the beginning with JP Morgan Chase. 50% gain is very real. I mean, honestly, that's even conservative from what I've seen when people are going from, let's say, a chaotic environment, not a whole lot of testing, very well automated, or the other workflows of testing are not that well automated, to a more automated environment. Even if you get, somewhat mature, you're going to see those kinds of gains. Those are real. Those are very real, measurable gains. And I think the reason that, you get those accelerations, generally speaking, is because you can automate all of the delivery processes, as you said, right? How do you accelerate software delivery? And in DevOps terminology, that's essentially what CI and CD is all about. You try to bring down the CI processes into, minutes or hours, not days. And then the CD process also, try to get it really, really quickly. The bottlenecks there tend to be testing related. How do you make sure you can set up a test environment, get all the tests done, make sure that the right tests, make sure you get the right results before you can qualify a build to say that it's a release candidate, and then take that qualified build and put it through a CD process that is, an approved for release artifact. And then finally, take an approved for release artifact and put it through a continuous deployment pipeline where you actually deploy it. And again, that's all about testing, making sure they recover if there's problems and things like that. So it's all about testing, honestly. It's a lot of the nuances of accelerating continuous delivery have to do with testing. I have a saying that I said that, continuous delivery is, you can't have continuous delivery without culture. So culture is the door to DevOps, if you like, but continuous testing is the primary key. That's how I think about it.
Excellent. Thanks, Mark. All right, let's get into believe the last question. How can dev teams mitigate, right, quality concerns that escape into productions, right? So that could be performance issues, it could be bugs, it could be whatever. But what should teams be thinking about in order to mitigate those quality concerns?
Well, when I think of the word mitigation, I think about, what can you prepare ahead of time to take care of, the possibility of things going wrong, and then what do you actually do when they do go wrong? So in that context, there are a lot of different tactics, techniques for mitigating quality concerns that escape into production. Probably the most dramatic ones are things like the progressive deployment structures. So there's like 7 different types of progressive deployments. Canary deployments, where you try your new code in a small subset of your deployment environment or its customers before you allow those changes to go further. And if they run into problems, then you can back off. Probably the more sophisticated one is feature flag deployments, where developers, while they're developing their code, decide what features or what code segments can be toggled on or off in a build, right? You don't have to reconfigure the build. It's literally toggles that occur as flags in the build. So during the whole pre-deployment and during deployment and even after deployment, you can turn off features, and that's a way to mitigate concerns. Doesn't require even to back up to a previous build or something to take care of an issue that you find in production. So that's, I think, the most sophisticated one. I think that's the one that is going to be the most important going forward when organizations get more and more mature. It gives you the most flexibility.
Excellent. And Marcus, your perspective here?
Well, I think Gitesh in the chat makes a good point. Like, what is a bug in production? How does APM help with finding bugs, assuming that bugs are functional in nature? And I think that there's a bunch of answers to that. I feel like that's a whole webinar in that one question, because we have sometimes the question was like, how many bugs are okay? It's like, well, I don't know what a bug is. It depends on your context, depends on your release cadence, it depends on your users. But I think that the way I would look at it is that APM is most likely to catch a functional bug if user is doing something and the API microservice that they're depending on for a web page to function properly, or a piece of the web app to function properly, if the API is misconfigured, it's going to show up in a functional way. And that user will then be thwarted from doing what they were trying to do, and there will be some sort of exception or backtrace or stack trace inside the log. And for some reason, they won't have been able to accomplish what they were trying to accomplish. So in this case, it's a configuration bug, and hopefully configuration is code. And as Mark said, you can roll these things back with feature flags, but it's going to present in a lot of cases as a functional bug because for whatever reason, it's not a DDoS, it's not a security issue. It is an API that broke and, contract whatever happened, and the user isn't able to get their task done. Still a bug.
Yeah, I'd like to interject here if you don't mind.
It's interesting. It's interesting that the question was about bugs in the chat, but in fact, we had this debate with preparing for this webinar. We called the actual question on the slide was quality, when we just explicitly distinguish bugs from quality because they're not necessarily the same thing. So I just like to interject that point, right? That you may have bugs in production that escape. Some of them may not be that important. It's really about quality concerns that I never want to worry about are the things that any stakeholder, whether it's a customer or other important stakeholder, has a problem with in using or administering product. in one way or another. Those are the things you want to mitigate. And bugs per se, just any errors may or may not be important. So I just want to point out that was an interesting thing. Yeah.
Excellent. Thanks, Mark. And then our last question around the big buzzword, AI. Marcus, how can AI help augment testing strategies to increase release velocity?
Very carefully. I think that I have had a lot of interesting success getting AI to help me accelerate some stuff I've wanted to do. I need to write a Python script that exports data from this thing to the other thing. I actually, confession time, I wrote a Perl script last week to parse some data and figure out some math. And I haven't written Perl in 22 years, so I used a little bit of ChatGPT to, by the way, I used ChatGPT 3.5 because I figured it doesn't matter how old the version of the thing the model you're using is, because it produced pretty much syntactically perfect Perl, if such a thing is even possible, that I was able to modify to my needs. And it was great. Honestly, it was fantastic. What I think the future of this is a little bit unknown, but I think in the next 2 years, I think AI will augment and accelerate and be your trusted assistant. But I would never, at the current state or even in the next year or two state, trust it without double checking and verifying the outputs, because it's just, it is asking for trouble to replace the most important part of your job, which is using your human brain to determine what, potential risks to your business are, and offload that to a model which has shown itself to be so deeply troublesome, problematic, non-deterministic, and hallucinatory as AI.
I'm a big fan of AI, but I also agree with Marcus's cautions, because certainly in the current state with the AI, Gen AI tools anyway, you definitely can't prompt and forget. You're going to have to work in small workflows and be very cautious about what you ask AI to generate, and then validate it as you go. But when you do that, and you do it systematically and do it with version management for every version that you generate of the answer, then it can actually indeed accelerate the different workflows, whether it's test generation, test analysis, test execution, and a lot of the different workflows associated with testing can in fact be accelerated. But I have a blueprint in my book for this. I think it's important to have some AI generated templates for every part of your workflow that essentially sets you standards for things like your test strategy, your test case, your test plans, your test results. So AI can then more effectively analyze it in a consistent way as you go. But I'm a big fan of AI. I also use, like Marcus, AI quite a lot these days. More and more clients are using AI to help them, not just accelerating, but also improving quality if it's controlled, right? The cool thing about AI is it's almost like having a online 24/7 brainstorming, partner.
Yep. As Gitesh points out, it's still a freshman. And I think that's a very good way to put it. I'm going to steal that, Gitesh. I hope that's okay. I'll try to credit you. Because I think that the thing that I worry about is not the fact that it's non-deterministic or hallucinatory. Like, you can keep a handle on that. You can keep an eye on it. What I worry about is the grift. There's a lot of really bad business models out there. And if you Google the AI subprime crisis, there's a problem right now with token subsidies and the fact that we're not paying the actual cost of any given model that we're using. We're not paying the actual cost of it. We're probably paying like 1/10 the actual cost of what it would take. And as soon as these companies that are in on the grift want to increase their margins to a usable level, it's going to create a huge problem with our ROI, especially as we start to embed it in our software and then resell that software to people. It's going to completely transform how we price these things. Now, that's a whole other topic, whole other webinar, but I encourage everyone to use caution around how you embed it in anything you're trying to sell to someone else. Keep it right where it is right now, as a freshman sitting on your right, helping you get through stuff, but be cautious about the grift that's out there and pervasive.
Excellent. Thanks, Marcus. Thank you, Mark. Excellent. Okay, let's get into some questions. We have a couple questions. So first question is, what is the best strategy to increase insufficient test coverage retroactively, especially without documented requirements of already existing features? That is a mouthful.
I hate to say that my answer to both of these is going to start with it depends. But what I would say to the first question, I'd love to hear Mark's perspective is always start with risk. Start with the risk to your business and figure out what is it that if this situation arises with my software, this API is misdeployed, or this thing doesn't work, or there's a shopping cart malfunction, like what is going to land me in the newspaper? What is the next CrowdStrike? What is the thing that's going to break the company if it goes wrong? Start with that. Just cover that. Don't worry about the code. Don't worry about the lines of code. Worry about making sure that you have confidence that your testing is nailing those most important questions. There was a story a long time ago that Etsy only ran 7 automated tests before they shipped. It's not true anymore, but it was true 10 years ago. And they said, if these 7 tests pass, we know we're going to keep making money, even if something minor goes wrong. So that's what I would start with, and then sort of work from there as you have time. I'm curious to get Mark's perspective.
I'm pretty much in agreement. I think the whole area of coverage measurement, you first of all want to get clarity around what do you mean by coverage. And I agree with Marcus that the most important thing to measure is really what are the things that are going to most impact the different stakeholders, right? Whether it's the customer or other people, depending on the product, what are the most important use cases? Those are the things to make sure you cover. It's not so much about how much of the code you covered or how many tests you covered. It's whether or not, the tests that you selected and run are the right ones, depending on, what the risks are and other major factors that are important to stakeholders. So that's what you mean by.
Okay, excellent. Thanks, Mark. And Mark, I will start with you for this next question from John. In your opinion, when is the best time to write or update test cases? Before, during, or after development? Which model is most efficient time-wise and most robust coverage and performance-wise?
I go back to the idea of test-driven development. In fact, in general, the best in-class organizations I've worked with do prioritize test automation, at least together, if not even ahead of writing the code, because the tests are the way you validate the code. If you don't have the tests, then you either have to create them after the code, which is going to slow you down, or if you don't have them, you're not going to be able to validate what you did. So fundamentally, you want to have the tests as prioritized at least at the same level as your code, and that means that folks in development need to really understand what are those important use cases. Make sure you've got tests for those at least, and do it in parallel or even add up it going.
So for me, I think it's an interesting question, and once again, I think that it depends with a favor towards before. You don't always have a choice. I feel like if you have a choice, do it before. I think there are a lot of cases where even the smartest people out there are, especially I think as you go along and you use your product a whole lot and you get to know it real well, you get to know where the bodies are buried and where all the warts are. You start to lose objectivity, and then you start to see bug reports from users, and you're like, oh, I should have thought of testing that. Oh my gosh. So sometimes you don't have a choice. But I do think that when a bug report comes in and it's a nice juicy one, especially one that reveals a regression or some sort of issue like that, it's important to write a test that will try to cover that as a regression test case in the future. So sometimes you can't cover everything. I think it's kind of, to me, it's intuitive that that creating tests afterwards allows you to create the most robust coverage in terms of, I see what the lines of code are. I can now write the test to tailor to make sure that those lines of code are executed during my test cases. But I think that that's not a very important goal. And it's also a false time savings, because creating them before you start making a whole lot of changes, especially with a large team making changes all the time, creating the test beforehand will ensure you have sort of, like I said, the support structures, the flying buttresses, if you will, in place in the code, holding everything together. Kind of a long-winded way of just saying exactly what Mark said.
Excellent. And an interesting question from John again, which I thought was really interesting, is there a way to determine if tests were generated by AI? So Marcus, I'll start with you, and then Mark, I'll like to get your perspective.
I don't know that there is. I mean, I'm going to say certainly not 100%. I'm not even sure it's 80%. I think that the biggest indicator for me would be non-idiomatic code, which means that the AI is not going to do that whole thing where you like compress a giant if-then block to a whole bunch of question marks and colons. It's not going to do that. So it's going to write out the whole if-then block, which may actually be a good thing. I think the first indicator, though, will be the comments. If it leaves really robust, complete sentence comments with capitalization and periods, that is a sign that it was written by AI, because I don't know a single living developer, and myself, I'm a prolific writer. I'm a very stickler about grammatical work. I never capitalize sentences or put punctuation in comments unless it's Java doc. So I think that that's an indicator, but I wouldn't say that there's a 100% way of finding out. Mark, you know anything else?
You want to be not just generating code with AI, you want to be generating against some standards or templates that you already used AI to help generate those. So it's going to be pretty clear if the generated code is following along your standards and templates or not. If it's just generated without that, I mean, clearly it's not going to be following, your standards and templates. So that's one way you would know whether somebody just went ahead and said, please create a test, and they didn't follow, whatever your AI test generation process is. So you want to have an AI test generation process, and that process will help you determine whether or not the tests that you are generating are in fact compliant with your own process. So I wouldn't generate it tests unless I had a defined process. And then you can use the process to validate the test.
And I've got one more question here. This person's just starting out. Is what are some important types of tests to do in today's digital landscape? I know it's kind of a broad question, but
But I mean, there's a bunch. Mark, you want to give a list? Let's see if I can think of
Yeah, I
anything.
mean, it's a crazy list, so I'm not going to list them all. But the main thing is with distributed systems, the modern distributed digital systems, it's all about making sure your contracts at the API level are correct and that they perform well, because things are interdependent through those APIs. So API testing certainly should be high on your list of priorities in contract testing. If it's a part of the system that is important for regulatory and compliance, then you definitely should have tests for that as well. And of course, capacity, planning, and chaos engineering gets especially important when you get into complex distributed systems. So these are the things in my mind, but where the bulk of the most risky problems tend to occur is in the interactions between these so-called simpler microservice type architecture components. It's the combination that tends to yield the bigger problems. So that's where I would concentrate, the highest percentage of high value tests on those interactions and the interfaces.
cool. Marcus?
I agree with everything. I just put a kind of a partial list in the chat. I think that one area that I'm trying to encourage people to start doing more testing is accessibility, which is a subset of functional testing. And part of the reason I want to suggest that is because there's a regulation in the European Union that's going to effect next June for anyone who has software that European users use. You're going to start being required to make it accessible. So you should be aware that that's coming and start to look into what it would take to be in compliance. The other reason I think you should do it, though, is because building accessibility into your product doesn't just help users and bring new people to your product. It also helps your product to be higher quality and more testable, as Mark was talking about earlier. Creating accessibility hooks actually exposes testability to your software, to your testing tools in a way that might not seem obvious at first, but which actually can do a lot to accelerate your velocity around testing and around development in general. So that's one area that I think is a little bit overlooked in history. There's a whole bunch of other kinds. And I think that if I were to rank them, I would say, I think that most issues nowadays come from config and APIs interactions, exactly like Mark said, contract testing, API testing, and making sure your config is code and your config is fluent all the time. And then I would, functional, that kind of thing.
Awesome. And Marcus, so I know we're close to time, but there are two questions that I want to make sure I get into. One is from Gabriel, who is kind of adding on to this or asking about the accessibility piece. Can you elaborate more on accessibility hooks and how do you approach on this?
I can elaborate very briefly, and then we can try to send out some in the follow-up email that we send out, some resources on that. One example of a hook would be alt text on an image, where you should alt text on either an image or on a link or anything like that, where you essentially give something what's called an ARIA ID, ARIA. I don't remember what the acronym stands for. I never remember what acronyms stand for, but it's a thing that accessibility tools look for to identify unique fields. So imagine, for example, you are visually impaired and you want to fill out a form on a web page and you have trouble seeing it. You can't see it for one reason or another. ARIA attribute will take that form and allow a screen reader to see it. And instead of seeing text field, text field, text field, text field, they'll see first name, last name, phone number, zip code. So the ARIA attribute will actually let the accessibility speech tool tell you what is on the form, but it's also something you can use in test automation to identify that field for interaction with a script, as opposed to giving it some horribly complicated XPath where you say, give me the third text field down the page or something like that. So it's a very nice way of instrumenting your test for automation and helping out your users at the same time.
Excellent. And then Marc Hornbeek, I want to give you this last question from John. Do you think requirements traceability matrices should be a required part of the product lifecycle?
Short answer is yes. I think I think too many folks, especially misinterpret, the agile concept of, working software over documentation. That doesn't mean you shouldn't have documentation. Doesn't mean you shouldn't have requirements. Doesn't mean you shouldn't have a system design. It all starts with having a clear understanding of, what are the requirements before you go off and implement things. There was I published recently, it's not new, but it was a good refresh. Dr. Ackoff against, compared to Deming's methods, where Ackoff talks about how discontinuous change is more important than continuous change. Both have valid perspectives, but the point is that, Ackoff's view is design is a discontinuous change. So if you have something that is, a new system, then you definitely need to have clarity around requirements before you run off and implement all, get into the weeds of ongoing change. If you have something that's a pretty stable product, that's not undergoing radical design, but just improvements, then even still, continuous change still requires clearly defined requirements for every one of the changes. Maybe not as exhaustive as an entire system, but I still believe, start with discussing and analyzing requirements before you implement tests or code, and you're going to be a lot more efficient in finding and fixing problems at that level than waiting until the code is implemented and tested in the lab and everything.
Excellent. Thanks, Mark. And Marcus, actually, we got one more. I mean, we're just having some great engagement here, and it's a great discussion, trying to keep it going. Marcus, we have a question from Ganesh. Isn't W3C compliance a standard for web apps?
Yes, it's W3C only ever recommends standards. There's no governing body that will go and fine people or arrest people if they don't comply, unfortunately. For those of you who don't know, my information is a little bit old, but I think that Safari, the Safari web browser, is only like 78% compliant to HTML standards, HTML5 standards. So that's one of the reasons we also recommend cross-browser testing, is like the difference between Safari and Chrome, even though most of the time it's not different, can be different, because Chrome is something like 98% compliant, whereas Safari is only like 78% compliant. So it is a standard, and I'm glad the standard exists. And that includes standards for accessibility like WCAG, the WCAG, which once again, I don't remember what the acronym means, but it includes all those standards. But outside of the European Union's future enforcement of those standards, it's not something that there's a governing body that actually will go and arrest people for making their websites look bad. It is a standard. Compliance is not mandatory. Oh
Excellent.
yeah, great question from Michael about embedded devices. Do you mind if I talk about that, or I definitely want to hear Mark's.
Well, we have time. I'm told we still have time, so let's hit the question. So embedded devices, build test cycle can be weeks or months for hybrid hardware software. Comments on best practices.
Right. So I'll pose the question to the longer question to Mark from earlier in the chat. You mentioned hours to seconds on CI, but for embedded devices which require hybrid software and hardware tests, manual CI can be weeks or months. Working to automate the hardware tests, but I would like to hear about best practices. Mark, any thoughts on that? Hardware testing?
That's kind of where I came from. I grew up in the networking world, and all of our testing had to do with nanocode, microcode, high-level code, and hardware, very high-speed stuff. You couldn't, the virtual world doesn't cut it, right? We're talking terabits per second and things like that. But you still have the problem of trying to get fast feedback to developers when they integrate with everybody else. So the way you do it is you have a lot of accelerated testing. For example, a lot of load testing in parallel with functional testing. So it actually does add challenges to the testing problem and the test network test topologies, for example. You're going to have a wider variation to go in parallel if you really want to accelerate the time from, to do a complete CI cycle or a CD cycle. The way you're going to speed it up is by doing accelerated testing, being very careful about what test you select, and having a lot of different test topologies available, on demand. So it's expensive test environments for sure. Some tests you can do in virtual environments, but a lot of them, like you say, require actual hardware to get the actual performance to get valid results. So that's what I think. In that environment, the environment setup and teardown tools are just as important as the testing itself because of all the different combinations, topologies.
Marcus, what are your thoughts?
Honestly, never really tested hardware before. That everything Mark said sounded right to me. I guess what I would say is that I always look at kind of this 2x2 matrix. On the bottom axis is like, are you testing for coverage or are you testing for risk? And then on the top axis, it's, are you testing versioned software or continuously testing? And in your case, you can only go so high on the versioned, but you should be able to go somewhat to the right as far as coverage versus risk. And I just think about everything in terms of that. If you have a test that you're trying to write, how long does it take to automate it? How long does it take to execute it? And is it a critical test to run or not? Hardware, honestly, it's a very different animal, and it requires a lot more because you have to ship actual physical things to the field. Truthfully, I think Mark covered it. I probably shouldn't. I probably shouldn't have answered.
Thanks, Marcus. I appreciate it. I think that's all the questions we have, so that's great. First, I want to thank all of our listeners for joining us today. Really appreciate it. Again, Marc Hornbeek and Marc Merrell for taking the time to share their insights, their knowledge, and their expertise with us as we help our companies and our listeners really figure out the best testing strategies that can, accelerate their software delivery, making sure that they're getting good quality software out to their users. Thanks again, everybody. Really appreciate it.